Section 3.5 is all about the connection between a function, its first derivative, and its second derivative. And so there's all these relationships. Remember, f gives the y values of the function. If f of a number is 0, then that gives us a root or a 0 or an x-intercept. If f is positive, the graph is above the x-axis. If x is negative, it's below the x-axis. Okay, that's f. And then we have f prime. If f prime tells us how the y values are changing, it tells us about the slopes. If f prime of x is 0, it gives us a critical value. Maybe there's an extreme value there. If f prime is positive, f is increasing. If f prime is negative, f is decreasing. And then we have the second derivative with possible inflection points and concavity. We've already seen this circle, and so we're going to combine all of these ideas now to be able to sketch graphs of functions. All right, so I'm going to kind of break down. Let's see what this information is giving us. Since f prime is positive on that interval, I know that f is increasing. Oh, that looks terrible. Let's try this again. Whoops. All right, so f is increasing on the interval from negative infinity to 1. F is decreasing on 1 to infinity. I also know, so that tells me that there's a relative max at x equals 1. All right, let me extend that page a little. Come on, can't get it. All right, there we go. Whoa, too much, too much. I also know now for part 2 that f is concave up from negative infinity to negative 2, and also from 2 to infinity. And f is concave down like a frown in between negative 2 and 2. So that tells me I have inflection points at x equals plus and minus 2. And then the last part here, that gives me the end behavior of the graph. That means I have a horizontal asymptote at y equals negative 2, and I also have a horizontal asymptote at y equals 0. All right, so we're going to pull together this and sketch a possible graph. All right, so 1, 2, 3, 4, 1, 2, 3, 4. All right, so I know that we had a horizontal asymptote at y equals 2. We had a horizontal asymptote at y equals 0. Okay, so now let's make this burnt orange. All right, so sketch a possible graph. It doesn't really matter how we start it. So I'm going to start it towards the left. Why not? So we have our horizontal asymptote on that side at y equals negative 2. We are going to be increasing and concave up. And so we're going to be increasing all the way up until 1. And we're going to be concave up until negative 2. So let's start with that. So we're increasing and concave up. Now we're still increasing, but we're going to be concave down. We're increasing until 1, and we're concave down. Concave down. Oh. All right. So we're still concave, or we're concave down from negative 2 to 2, but we're going to decrease now from 1 to infinity. So I'm going to be decreasing and concave down. And then I'm concave up again, so I'm going to be kind of like, oh, I went too far, because I'm trying to hit that horizontal asymptote as well. There we go, maybe something like this. So that's a possible graph. You just kind of have to get the pieces and put them together. All right, so let's look at example 2. All right, we're going to start with the first part. We're going to start by thinking about this as, pretend that this is f. Where is f decreasing and concave down? So let's highlight the parts where it's decreasing. Here and here, and concave down. So it looks like maybe just those pieces, -7 to -5, and also from 2 to 3. All right, let's see, where is F increasing and concave down? So increasing, looks like concave down there, and then increasing concave down. Oh, I picked concave up, didn't I? Whew, that'd have been a bad mistake. All right. Increasing concave down. Looks like maybe only that part right there. So from -1 to 2. And so where does F have inflection points? Well, it looks like x equals -5. It changes from concave down to concave up. -1. Looks like it changes from concave up to concave down. And then maybe at 3, concave down to concave up. All right, so that's that one. Now we're going to imagine that instead of this being F, this is a graph of F prime. So where is F increasing? Remember, F increases where F prime is positive. So now we just need to list where F prime is positive. So it'd be -7 to -5. And then again from -1 to 5. Notice I'm not including 5 because it's 0 there. All right, and 5 to 7. Where does F obtain a local min? All right, before we look at the graph, let's think about that. What are we looking for? We want F prime for a minimum to go from negative to positive. So let's look at the graph. Where does F prime go from negative to positive? It looks like the only place that occurs is at x equals -1. All right, where is F of x concave up? So remember, we want the second derivative to be positive, so we want F prime to be increasing. So where is F prime increasing? Where are the slopes positive? Let's get rid of that. All right, looks like here and here. So -3 to 2, and then 5 to 7. And where does F have an inflection point? F prime of x, we need it to change from decreasing to increasing, or F prime changes from increasing to decreasing. So F prime changes from decreasing to increasing at x equals 3, or x equals -3, sorry, because F prime changes from decreasing to increasing. And then there's an inflection point at x equals 2, and that's because F prime changes from increasing to decreasing. And then again at x equals 5, because F prime changes from decreasing to increasing. All right, so let's get rid of that. And now we're going to imagine that this is F double prime. Okay, so you're imagining that this is F double prime. Where is F concave down? So F would be concave down when F double prime is negative. So that looks like it's only here. So F is concave down on -5 to -1 since F double prime is negative. And then where does F have an inflection point? So we're looking for where F double prime changing signs. Looks like at x equals -5 and at x equals -1. And again, that's because F double prime changes signs. All right, so the next part is graphing. So I think we'll save that. We'll save that for tomorrow.